What's up, skeptics? Welcome to another episode of Reason to Doubt, your source for all things skeptical. I'm Jordan, joined with Jared, and today we're going to be talking young Earth creationism. This is the fundamentalist sect of Christianity that believes that the book of Genesis is a history book, that the history of the world follows that exactly, and therefore the Earth is only 6,000 years old. Sometimes they go as high as 10, definitely no higher than 10,000 years, though.
Yeah, and this video comes to us to the Creation International Ministries.
CMI, Creation Ministries International.
Got it backwards, yeah.
Yep. So. I mean, there's so many of them. This one is a splinter group of some of the more popular creationist groups, but I think this video actually has some pretty good production value. I was actually impressed with the level of effort that went into the editing and like the cinematography. Obviously, no effort whatsoever went into the actual evidence or answers, but I mean... You know, you got to cut the budget. That. You got to cut the budget somewhere, right? And I mean, where are you going to cut it? You know,
the production level is very high and really good audio too. So,
right. And actually, one of the reasons we decided to respond to this video was because these creationists are probably more honest and forthright about their reasoning and the motivations than any other creationist I've ever seen. They really don't bury the lead. Right up front, this is one of the first things they say.
You can't have death and suffering before Adam's sin. And that means the whole evolutionary story is theologically impossible. So that started me on a real journey of discovery and reading. And I discovered that, hey, I could actually believe what the Bible actually said without having to, as it were, leave my brains at the church door, you know?
So this is really the whole deal. This is taking the mask completely off and saying the quiet part out loud. This gentleman, his name is Mark, he starts with his conclusion. He believed, for theological reasons, that death and suffering can't happen before the original sin of Adam, before Adam eating that apple, which is totally Eve's fault, you know, that sort of thing. Before that, that's when death came into the world, right? Well, if that's true, then evolution has to be false. And then he went and found the answers. And wouldn't you know it, the evidence corresponded to what he wanted to be true. Crazy how that works out, right?
Yeah. Yeah. He didn't leave his brains at the church door. He just left his brains at his house before he left.
Right. So this is clearly just starting with the conclusion he wanted and working backwards from there. So kudos for being honest about it, but this isn't exactly the best way to get to truth.
Yeah. And this is something I think that will come up throughout this video as we're looking through this is the level of cognitive dissonance that's going on. And we'll point it out when we get there, but this is a prime example of that.
The thing is, the millions of years always place death before Adam.
Right.
So if you have death before Adam, you don't have a meaningful gospel message to share. So that means the millions of years actually undercuts the gospel. And that was a revelation to me.
It would also be a revelation to the billions of Christians who don't have a problem with this at all, including like the Catholic Church. Obviously, these people would probably say that they're not actually Christians, you know, but, you know. So I mean, the Pope doesn't have a problem with it.
This is clearly only a problem for you if your theology is such that the earth was perfect at one point before when Adam was there, right? So,
and there are plenty of other ways to interpret the Bible, to interpret the book of Genesis. And in fact, the majority of Christians, this might feel weird if you're an American, particularly if you're in like a conservative part of America and you're surrounded by a certain brand of Christianity. But looking at the globe, the majority of Christians don't think this way.
Right.
That this is definitely a minority position. How I know that I was raised young Earth creationist, but when you were growing up, how common was this view in your church?
We didn't talk about it. I don't ever remember having a sermon or a service where this was discussed at all. Obviously, we talked about creation, Adam and Eve, but the idea of death before or perfection before, like, it was never talked about. So I guess not common at all.
Yeah, there you go.
I like to summarize it like this. I say I discovered two key things. Number one, that I could believe what the Bible says because the evidence all points that way, and we'll talk about some of that a little later on. And the second thing I discovered is that I should believe it because the Genesis account is the basis of the gospel.
Okay. Remember that confirmation bias we were talking about?
Yeah, here it is again. And so what's happening here, and assuming that his story is genuine, and there are people who have this story even if his isn't, if you go to find an answer, you are likely to find that answer, right? So this should be a warning flag to us as skeptics. If you're ever like approaching a problem and you just find all the evidence is like pointing exactly the way that you thought it would, or exactly the way you would like it to point,
Right.
maybe take a step back. I mean, you might be right. You might have just gotten lucky and turns out you were right all along, but maybe not though.
Yeah. Warning flags should be going off if you're a skeptic at all. And we'll find out in a little bit. He does claim to be a skeptic, doesn't he? So
that is a thing he says.
So how did you find out the evidence that does support the biblical history, and what did that do to your faith?
Well, reading that book by Billy Graham really started me on a journey, because I realised I had to rethink my science now. And I started to buy books and read them and so on. And I remember the first one I ever bought and I started to read through it very skeptically. So I had a pencil on putting question marks down the margin and not sure about that. I got to about the third or fourth page and it suddenly dawned on me, this guy's right. Wow. It's actually true. I can trust the Bible.
Yeah, he was going through it so skeptically. He was doubting, was making notes, and he made it all the way to the third page of the first book. This is the first book.
There's so much going on with this. Okay. First of all, the book by Billy Graham's what got him to say, I need to look into the science, right?
Because when I think science, I think Billy Graham, right?
But then, yeah. Okay. I mean, dude, but he's honest with it. First book, third pages. It's all right. Everything I believed before, been confirmed. I'm good to go.
That was close, man. This actually, so I'm not convinced this. We'll get into honesty later, but
right, sure.
If looking at the criterion of embarrassment, like if I was going to make up an account, I would not have me come to my magical realization 3 pages into the very first book. So
yeah, I mean, come on, give yourself 2 books at least before you, or the last page of the first book, maybe, right?
Have some kind of arc with like some growth and whatever, definitely. He needs to take a page from what is it? James Warner Wallace?
Yeah.
Or Lee Strobel would be better. Lee Strobel has the whole thing where he's like the hard-bitten reporter, like
wrestling with it the whole time. Yeah.
Yeah. Definitely missed opportunity.
So it's clear he had a conclusion he wanted to get to, right?
Yeah. He was not examining this book skeptically, like at all. It's like, man, I need to be skeptical about this. I need to really examine this. Let's look at it. Oh, thank God. I was right all along.
Usually 3 pages in is like the introduction too, right? He's like, I want to thank my mom and my uncle. And
he's like sweating bullets the whole time. He didn't even make it past like the intro, the acknowledgement section. So now that we've gone through his super skeptical method and we understand his definitely not at all biased reasons for examining this evidence, now let's dive into some of the actual scientific evidence that he's talking about.
How do we determine the age of something?
Well, I know my age because I've got a document at home called a birth certificate, which thankfully my parents found. But just a shade more, actually. I'm glad you said that, Scott. And so I have an historical record. Now, there is no scientific experiment you can conduct on my body, not that I would let you, to determine my age. So making observations in the present actually can't permit you to determine an age. So you really need an historical record.
Can I just pick you up on that? But
sure.
we could guess, right? There would be your cells. Would they be slightly different to a baby's cells?
Sure.
But I think your point.
Get a rough estimate, but you can not with any precision. Is my point.
Right. Yeah. Got you.
Are you kidding me right now? Are you serious right now? There's no test whatsoever that anyone could run on this clearly old man to determine his age with any precision.
I'm sure all the medical examiners down at the city morgue have something to say about this, but
yeah, seriously, this is something that happens literally every day. Coroners determine the age of people that they don't know the age of. But But like just on the face of it, you don't even need any specialized. Look at him. Look at him. He's like, okay.
He's
You may
25,
not,
Jordan.
yeah, okay, exactly. And the only reason that joke works is because he's clearly old.
Yeah.
Right.
Oh man.
It's insane.
But
It's just
even
insane.
more, there are actual scientific, tests you could run on somebody alive or deceased that you could determine, and even down to
Sure.
like the gene level and like the telomere lengths and all of that stuff. There's stuff you can do. Like
there's all kinds of markers of age, and you can even tell the difference between damage from age versus damage from disease. So it's not saying like they could tell within the day or something like that, but they could get close enough.
Pretty darn close. Yeah. This is so what I thought this was interesting and important to highlight was because it shows a fundamental lack of science and the capabilities of science. Right from the get-go.
A fundamental lack of understanding or a purposeful misrepresentation of the capabilities.
That too, yes.
Because the words they're using, well, they couldn't determine it with any precision. Well, what does that mean? What do you mean with any precision? Because that's to say that precision, they can't. Yeah. It seems to be saying, to take it as charitably as possible, they're saying, if you can't tell it perfectly, then you can't tell it at all, which is, of course, nonsense.
Now, the problem with that is that you can't actually make observations in the past. Science only works in the present because we've only got the present. We don't have the past at all.
You only got the present. Can't say anything about the past. That's why, like, if someone were standing next to his car with like a baseball bat and his car windows are all broken up and like his thing's all dented and there's like a thing written on it like Kilroy was here or something, like you can't say anything. Like you're only making an observation in the present. You didn't see anybody hit this car. So, I mean, who knows what did it, right? No inferences can you draw here. This is ridiculous, obviously.
This is ridiculous.
There's no fundamental difference between a person seeing like a detective investigating a crime scene or something like that. There's no fundamental difference between looking into the past to that extent and looking into the past further. The only thing different is the methods.
This is a clear Ken Hammonism. I just made that word up. Of you weren't there, you didn't see it.
Yeah. I am tempted to try a terrible Australian accent. Just pretend I did. You all know what he sounds like. Pretend I made an excellent Ken Ham impression, and I'll spare you the actual attempt.
Perhaps I could give you an example.
Yeah.
Let me use this glass of water. I'll try not to spill it on my laptop. So I've got some water in this, and let's imagine that this was sitting underneath a dripping tap.
Okay.
Now, if I measured the rate at which the tap is dripping, and then I measured the volume of water in the cup, I could calculate how long the cup has been under the tap, right?
So that you've got the dripping rate, and then you've got the volume that's in the cup.
Yep.
And then you just say, well, okay, the volume, and you've got the dripping rate. You can calculate the age.
Yeah.
You just calculate the age. You got the dripping thingy, and then the cup, and you just calculate it.
Right.
Yeah.
So I'm going to cut him off there. He just clumsily talks about constant rates and the assumptions you need to use in his analogy. And he talks about things like, what if someone had turned the water on hard earlier, but you didn't see that? What if the cup started with water? What if someone poured some out before you got there? Oh, but like all these sort of what if scenarios, right? And
He's
then
setting it up.
He's setting it up. And this showcases both kind of a problem, but also a tactic that professional creationists use, is that they'll use analogies very heavily because analogies are simple, they're easy to understand, and then they'll say, oh yeah, this science thing is just like that, but never actually do the work to show that it's just like that. Creationism sounds fine if you're primed to believe it, and if you only go as far as vague kind of hand-waving analogies. But if you have to
only go as far as the third page.
Right. Yeah, exactly. If you have third page level skepticism, then it sounds great, right? But if you actually dig in and do the work to show like how the analogy doesn't work in reality, then it just falls apart. So what he's setting up for is radiometric dating, right? And so he's going to talk a little bit about assumptions, and we're going to break those down.
And that's part of the reason why I brought this video to Jordan was because I knew he liked talking about radiometric dating, and this was going to get him riled up. So we'll see if I succeeded. So
I have been known to get a little passionate about radiation from time to time.
That would be applying uniformitarianism to take the volume of water, divide by the drip rate, hey presto, we get the age. So you can think of radiometric dating, for instance, of working a little bit like that. You have a radioactively unstable element called a parent element that decays at a certain rate to produce what's called the daughter element. So if you can measure the ratio of the parent element to the daughter element in your sample and knowing the rate of decay, you can then calculate the age of the sample. But you're measuring the process in the present. You're measuring the volume of parent element and daughter element in the present. But you don't know the initial conditions, how much parent and how much daughter were in the sample to begin with. Maybe some parent element has been added to or removed from the sample in the past, same with the daughter element. In fact, there are something like 7 independent assumptions you have to make to be able to determine the age of your sample based on measurements in the present.
Wow. And so is there anything that can ratify those assumptions, or is there any way that we can see that those assumptions are correct assumptions? Because I guess I'm asking, is there a way of calibrating this clock? Because this is really important what you're saying, because when people think about the age of the earth and it's a stumbling block for Christianity and the biblical history of the earth, it's mainly to do with radiometric dating.
This was an incredibly insightful question. Like, spot on by this guy. I don't know if it wasn't in the script or something. I don't know. But that is an extremely
his true skepticism was going off like, wait a second.
Right. Oh, no. He had to shut that down. Yeah. So he asks, okay, we've been talking about these assumptions that they make for radiometric dating. Is there a way we can vet them? Is there a way we can see if those assumptions are valid, if they're good to use? Extremely insightful. So naturally, they never answer the question. Like, we stop the video there. They never come back to that question ever again. Mark talks a little bit about rock layer deposition, and then he transitions to a discussion of outliers, and then they never come back. But they act as if they did answer it. They act as if they answered the question, and the answer, was no, you can't vet them. Right? It's very sneaky.
Yeah.
The way that they did this. So they asked a question. It sounds like to me, it's if this was intentional, then it could have been a tactic to, this is a question the audience might have. Let's ask that question so they know we asked it and then move on without answering it.
This is a tactic in car sales where it's called bypass the objection. So you acknowledge it, bypass it, keep on moving.
Right. And because you
do you know
acknowledged
why? Yeah. Do you know why we do that though?
Because I don't have an answer.
Well, yeah, but I think there is an answer to this question. What is the answer to this question?
Well, the answer is yes. The answer is yes. We can absolutely verify this. And the entire rest of the video relies on this falsehood, right? So because of that, I think it's good for us to pause and answer the question the way that they should have, right? So let's talk a little bit about radiometric dating and how it works and the assumptions that do go into it and why those are good assumptions, right? Because every method has assumptions. So the question is not whether you have assumptions. The question is whether those assumptions are valid, right? So just to start off with, I'm going to be talking generically about radiometric dating kind of just as a whole class. There are a huge variety of different methods to radiometric dating, and they all have their own idiosyncrasies. Some assumptions only apply to some of them. The assumptions I'm going to be talking about apply to all of them, but just know that the specifics might vary depending on the specific dating method you're talking about, right? So the basic idea of radiometric dating is that in nature, there are unstable isotopes. An isotope is just like an atom, okay? And they're unstable, which means they'll decay, they'll disintegrate at some point. And so that disintegration, they'll emit some particle and turn into something new, okay? If you measure the ratio of the old stuff, called the parent, and the new stuff, called the daughter, you can infer an age. Just like he was talking about with a dripping tap, it's just like that, okay? Except it's exponential instead of linear. So there are some assumptions that go into this. Assumption 1, the amount of daughter, the new stuff at the beginning, is either known or it's more usually taken to be 0. So there was no daughter to begin with, or if there was, you know how much. There was no parent or daughter added or taken away throughout that time. You didn't get any new parent added, you didn't get any new daughter added, whatever. And throughout the entire time being examined, the rate of radioactive decay hasn't changed.
That's 3 assumptions. I thought there were 7.
Yeah, he did say there were 7, and they never say what those 7 are. And I actually looked at CMI's website, and the only place they talk about the number of assumptions, they give the 3 I just gave. So I don't know what the other 4 are. So whatever. I mean, he didn't see fit to tell his audience either, so I guess we'll just skip them. Okay.
Well, assumption is bad, so more is more bad.
Yeah, more is badder, right? Yeah. Definitely. Yeah, 7 bigger. Okay. Yeah. So 3 assumptions. Let's take them one at a time and see if they are reasonable. So let's look at these assumptions one at a time. And what we're looking at is to check if these are reliable by 1, them applying most of the time or all of the time. So they should be applicable the vast majority of the time. They're not going to be applicable all the time because nature's messy. So that leads us to 2, when they don't apply, when the assumption is violated, we need to be able to tell. So we are assuming that it's X, but if it's not X, then it shouldn't be a mystery. It should be obvious in our measurements. Okay? Because if the assumption is violated, then you know, so it's not a problem. So let's start with assumption 1. The amount of daughter at the beginning was known or was 0. And for this one, I'm going to focus on a specific dating method, uranium-lead, but similar things apply to other dating methods. So in uranium-lead dating, you've got like a lava flow or something. When it cools down, crystals form. In particular, there are crystals of zircon crystals. They take in uranium and they reject lead. Lead has a very hard time being in the crystal when it's formed for physics reasons I won't get into. Once it's crystallized, so it's a closed system, the assumption is nothing can enter or leave. We'll get into whether or not that's actually true later. And then the uranium decays, turning eventually into lead. Measure that ratio of uranium lead, get a date. So, like I said, the zircon crystals don't incorporate lead. So when it's closed, the daughter element is kicked out. And so the idea is that it's 0 or very small, not very much, right? This assumption usually works. Because, again, physics reasons. But it's not perfect. Occasionally, very little gets in. Very little is not none, right? So what happens if you do have a little bit of lead? How can you know how much was in there? Well, in this case, there are different isotopes of lead. There's different flavors of lead, okay? You've got 2 flavors of uranium. They turn into 2 different flavors of lead. U-235 turns into lead-207. U-238 turns into lead-206. Lead-204 is non-radiogenic, meaning it doesn't come from radioactive decay. Okay? So there's radiogenic stuff that came from the uranium. There's not radiogenic stuff that's just there already. All lead is chemically identical. Doesn't matter what flavor it is, chemically it's the same. And so any process that incorporates lead into the crystal will incorporate all the lead into the crystal. So if you detect significant amounts of that non-radiogenic lead, the lead that doesn't come from uranium, if that's in the crystal, then you know that lead was there to start with, and you know approximately how much.
And then you can subtract that and keep on moving.
Right. Almost always, it's so small that it doesn't matter and you can safely ignore it. It won't affect your ages. But if it were, for some reason, very large, you could tell. It would not go unnoticed, right? So for uranium and lead, you've got this assumption. The assumption works almost all the time. And if it didn't work, you could tell. The assumption's valid. Additionally to that, there's another thing that you can do called the isochron method. I'm not going to go into the details of the isochron method because it gets kind of mathy, and I don't want to derail this whole thing into it. I do have a Google Doc, which will be in the description, that explains it. Basically, what happens is if you have a daughter element and so you've got the daughter that's being decayed into. If there's a non-radiogenic isotope of that same daughter, you can do some very fancy math that eliminates all of your initial conditions from the math. You can actually calculate how much daughter was there at the beginning based purely on things you can measure today. So I'm telling you that's the case. I have done the math. You can check me in the description if you wish, but mathematically you can remove that assumption entirely. So if you don't believe me about the lead thing, this is another way you can bypass this assumption.
So it sounds like science has multiple ways to verify this assumption, and they do
Sure.
that. Yeah.
And this is not something that scientists are like unaware of. Of course they're aware of it, and they're going to handle it. They're not going to just like throw up their hands, right? And again, it depends on the method. There's just to throw another method out there that'll come up in a little bit. In argon or potassium argon dating, argon is a gas, so it's assumed that most of the gas gets expelled, and then whatever's there, like it crystallizes, so there's no gas in it because that's been constantly being degassed. But that's not always the case. Sometimes a little bit of argon gets captured in there. How can you tell? Exactly the same way. Not all argon comes from radioactive decay. If you see that non-radiogenic argon, it's the same thing, right? So again, this is not a problem. So let's move on to number 2. Number 2 was no parent or daughter isotopes were added or removed. So basically the system was closed through the whole time, right? That's important because if you go back to his dripping water assumption, if someone added some water or took some away or whatever, you'd get an incorrect measurement. Now, this may be shocking, but nature's messy, and this crystal has been sitting around for 1 billion years. It might have gotten damaged over that time, right? So this assumption actually gets violated with a fair amount of regularity. For instance, in uranium lead dating, the uranium is decaying, it's emitting radiation. That radiation can damage the crystal, and that can cause it to weaken, and sometimes water can leach out the lead. Okay?
Well, there you go. Creationists are right.
Boom. Yep. We're done for. This is exactly what they warned us would happen. You can't use it, throw it away. No. So here's the thing. Remember our second thing. If it happens, it needs to be detectable. Well, one of the reasons uranium lead dating is so nice is because you've got those 2 different kinds of uranium, right? U-235 and U-238, which decay at different rates. U-235 decays faster. So you have 2 independent clocks that are running at different rates, but if everything's worked the way it should, then they'll give you the same date. If the crystal's been whole the whole time, there's been no leaching or whatever, the 2 clocks will agree.
So this is like in Back to the Future when Doc sends Einstein into the future and their clocks are different now.
Yes. In fact, it is exactly that with no nuance whatsoever. Yeah. So you've got 2 independent clocks, right? If water came in and leached away some of the lead, remember all lead is chemically identical, so it's going to leach it away at the same rate, but it wasn't deposited at the same rate. And so what you'll get is the 2 clocks won't agree anymore. They'll be discordant. Okay. So you can make a graph. If the 2 clocks line up, it's called concordia. If they don't, it's called discordia. And that is a clear indication that the environment wasn't kept whole the whole time. Like there was some kind of disturbance. Now, scientists do have methods for dealing with discordant dates, and they can still get useful information out of that. So like that's also not a problem. But like leaving that aside, even if that weren't the case, they can tell again if this assumption were violated. So it's not like it's going to be violated and they won't know.
So in this example, if we did find something that had discordant dates, basically we would say, okay, this sample's tainted. We probably shouldn't use this if we're looking for an accurate.
So like I said, they have methods they can use to get around this and still get information. But it may be that because of the damage to the crystal that you can't get those 2 clocks to align, even with their better methods. And if that's the case, then yeah, this is damaged. We can't use it, so we're not going to use it. Right.
But you could just look for a crystal that was like 20 yards over in the same spot and maybe use that.
Exactly. One. Right. So if for some reason you had to avoid discordant dates, then that is a thing you could do. You just had to be willing to take more samples until you found ones that weren't messed up over time. So another thing, just like as an aside, most of getting parent to like get shoved into this crystal is more rare. More often stuff's being leached away. Right. And it's often the daughter, like the lead in this case, is being leached away. If you do that, that'll actually make it look younger than it is. Because the more daughter is there, the older it is. So if you take daughter away, it'll look artificially young, which is the opposite of what the creationists need.
So they would actually want you to do this?
Yeah. So like it also doesn't help their case, but Okay, so that's 2 of 3. The last one, assumption 3, is that the rate of decay has been unchanged for this whole time. Your dripping water, whatever, it hasn't changed. Okay. This is the most solid assumption of the 3. Now, we're dealing with rocks sometimes that are billions of years old. And people will say, well, you've only been looking at radioactive isotopes for like a couple centuries. How can you know that it hasn't changed in the last 2 billion years or 4 billion years or whatever, right? Well, here's how we
there.
can.
You
weren't there.
didn't see
You didn't see it, right? Well, with a few isolated examples, radioactive decay rates do not change regardless of pressures, regardless of temperatures, regardless of whatever we do to it, because it's a process that happens entirely in the nucleus, in the center part of the atom. Okay. Most of what happens to an atom is mediated by the electrons. And if you want to envision it, you've got a uranium atom. So you've got a nucleus, and it's got like 90, I think it's 92 off the top of my head, 92 electrons between it and the outside world. If you're the nucleus and like the nucleus is like a golf ball and it's in the middle of a stadium, the outermost electron is like past the parking lot. There's a lot of space, right? There's a lot of insulation. And so nothing's going to get through all of those electrons to affect the nucleus is basically what it boils down to. Not there's more to it than that, but like that's good enough. So basically, and if we could do this, if we could use temperature or pressure or something to make decay rates change, that would be huge. It would have commercial applications. We could make tons of money based on that. You know, it would help with running nuclear power plants, for example. So if we could, we'd do it, but we can't. So now, I said with a few isolated examples, creationists will always, whenever this comes up, they will point to a couple lab examples. They're like, oh, look, they took this radioactive isotope and they did this, that, or the other. They put it under pressure or whatever, and they changed the half-life by, 1,000,000% or something. Look, the half-life can change. What they will never tell you is the specifics of what radioactive decay and what they did to change it. And the reason they won't is because not every decay is mediated the same way. So I'm going to get a little bit in the weeds here, but there are multiple different ways a radioactive element can decay. Okay. Most of them is just spitting something out, but sometimes one of the ways is it can suck an electron in. So the nucleus is there, it eats an electron, one of its neutrons turns into a proton. It's called electron capture. Okay. Well, if you strip all of the electrons from the atom so it has no electrons to eat, well, now it can't decay anymore. You've changed the half-life by infinity%, but that did okay, so yeah, in that case, yes, you can change the half-life by physical processes, but that has absolutely nothing to do with radioactive decay.
Right, yeah.
Because in order to do that, you'd have to turn it into plasma, right? And they've also done other things. If you don't necessarily need to strip all the electrons if you put it under immense pressures. We're talking pressures you'd get down in the core of the Earth. Then you can change it by a couple percent. None of these experiments have anything at all to do with the conditions you do radiometric dating in. So they don't apply. But creationists will just point to an experiment, not explain what that experiment means, and then go from there.
Okay. But Jordan, counterpoint. Maybe physics worked different back then. And so the physics you're using now didn't apply back then.
Yeah. I mean, again, I wasn't there. So how could I possibly know? One of the ways creationists get around this, like you said, is by changing physics. They'll say, okay, look, this thing looks like it's 2 billion years old, but what if decay went faster in the past, right? And so you got 2 billion years worth of decay, but it all happened, usually they'll put it at Noah's flood. The problem is that when things decay, they release not just a little particle, but they also release heat. There's energy that is associated with that particle being ejected. And if you release 1 billion years worth of heat in a single year, you vaporize the Earth's crust. It's worse than that because the potassium in Noah's body would boil his blood. It doesn't work. It physically can't happen. It would destroy all life on Earth many times over.
If you want a gruesome recap of this, you should check out one of our previous episodes on Young Earth Creationists, where Jordan goes into very fine detail on this process.
Yes. But I can do you one better though, because in addition to it just being physically impossible, we can also look at things that happen in the present and that we can empirically tell us that physics hasn't changed, at least for the past 2 billion years. So in this case, I'm referring to the Oklo Natural Nuclear Reactor. So 2 billion years ago, in Africa, there was a nuclear reactor that was perfectly natural. No humans were involved 2 billion years ago. A naturally occurring nuclear reactor. It's the coolest thing that has ever happened in the history of the world. I'm not going to go into it because it's not relevant to this video, but Google it or ask me in the comments and I'll definitely tell you. Anyways, it happened. And one of the ways we know it happened is because in the ground, there are atoms known as fission products that you only get in certain concentrations if fission happened, right? So if fission happened, you get a distribution of atoms of a certain type, and that we see that in the ground. Well, what determines that distribution are some laws of physics, the fine structure constant being one of those important ones. Because we can observe the same distribution in the ground from 2 billion years ago, or from whenever it was in the past, as we would observe from a fission reaction today, that tells us that in the intervening time, there was no change in the fine structure constant and certain laws of physics, because it's not just good enough that it was the same. Like maybe it changed in the intervening time because the fission happens, but it takes a long time for the whole decay chain to work its way through. So if there had been any significant change in physics in that 2 billion years, we would not have the observations today that we have. And this is, I think, points to something that undermines the point he was making before, where like you only have the present, you don't have the past. Well, the past leads to the present. What happened in the past gets us to today. And so we don't have to like guess or take it on faith. We can say, okay, suppose that this was true. What would we see if that were true? And suppose this other thing were true. What would we see if that were true? And then see what we find. And if it matches one and not the other.
So what you're saying is, when I asked a question, are there any answers to the assumptions question, I shouldn't just go on to the next topic, but I should actually look for answers.
Well, that depends. I mean, is your goal to get to the truth, or is your goal to convince your audience that very smart people agree with them? You know,
that's
like,
my goal.
Yeah.
Yeah.
And this is completely typical for creationists. The goal of creationist apologetics is not to find the truth. The goal is to lie for Jesus. They want to convince their audience that smart people have looked at this question, so you don't need to look at it. Make sure to enforce that echo chamber. That's all it is.
Awesome. So I think that was the most succinct recap of radiometric dating and why we can know it's reliable, and a detail of the assumptions that you've ever given.
I tried really, really hard to simplify it and cut down as much jargon as I could. I have a little bit of blindness when it comes to this stuff. And so like I try to make it simple, and then I show it to like Jared or my wife or something. And if I just get blank looks, then I go back and like simpler. You know?
Yeah. Well, I appreciate that. So what do we do with this now? In terms of the video sense?
So we're going to continue on with the video. They are going to assume that these assumptions are not answerable. But what we're going to do is we're going to continue to walk through it, armed with the knowledge that these assumptions can be vetted and we can know, and we'll comment on it as it goes, because it's going to be relevant throughout.
Okay.
So really, are you saying the only way we can truly determine an age is if we have someone that observed it at the time?
I think that's exactly right.
Yep.
And the best possible historical record is a written record from the eyewitness. The earliest written record we have, we find in Genesis chapter 1, verse 1, in the beginning, God created the heavens and the earth. And it says on that first day, created the earth, light and darkness were separated, day and night, there was one day.
Yes.
So that's the very beginning, and that's when the written record of history commences. Now, people say, oh, but hang on a minute, there was nobody there then. And yes, but God was there, and he is the eyewitness of what he did in that creation week when he was speaking the universe into being.
Yes.
So that's the eyewitness, reliable, written record. Written through the agency of human hands, yes, but inspired and guided by God's Holy Spirit to write only what was true.
Bro.
Okay. Well, okay. First of all, this is demonstrably false, that this is the oldest record. The Bible is not the oldest thing we have ever written by humans. But even if it were true, at best, you'd have the writings of people, and they don't even claim this, but if assuming he was right, you'd have the writings of people claiming that they were writing a history, and that they're true because they wouldn't lie to you. Trust me, bro. Like, I wouldn't lie to you because God told me,
No, Jordan, this is the oldest, most reliable written record ever.
And how can you know it's reliable?
Because
the book said so.
Yeah.
And the book wouldn't lie to me because the book said it wouldn't lie to me.
I just can't even
Yeah.
This is one of those outsider tests of faith. If you were to apply that same logic to any other book in the history of humankind, you would laugh at it.
Yeah, exactly. Like any other claim in any other context, even they'll use this logic here. They don't use this logic in any other facet of their life. Absolutely not. But because it's the story that they've grown up with, because it's the tradition they were raised in, it gets a pass.
Well, also, to go back to the earlier thing, since we can't use radiometric dating because of the assumptions, and there's 7 of them, so we can't use them.
Yeah, which is more than 3.
We have to have, and we can't observe in the past. That means we have to have, for our thing to work, a eyewitness. So we are assuming there was an eyewitness for our certain viewpoint, right?
We're assuming that the thing we have written today accurately transcribes the testimony of said eyewitness. Correct. Now, he's going to say, we know that because God said so. But again, we don't have the writings of God. We have the writings of people who said they're writing from God. Well, they didn't even say that.
They don't even claim that, right? Yeah, exactly.
They actually don't. There's nothing in Genesis that says, oh, by the way, BT dubs.
God said this.
Yeah, God said, it's not like that. That's pure tradition. But yeah.
So people tend to agree roughly on Egyptian history, for example. I know there's some discrepancies. But what we're saying is you don't go much further back and you get the start of all written history, and that was biblical written history. But some people want to believe that we can go much further back than that. And the way they need to do that is through these radiometric dating methods, which you talked about having a number of assumptions.
Yes. But assumptions that are driven by an initial belief.
Yes.
About the process of creation.
Yes.
Okay, so for the evolutionist, then, person who believes in evolution, the deep time, the millions and millions of years, is an integral part of that whole story.
So there's nothing that we said in our discussion of assumptions that required deep time. The deep time was not a part of our assumptions.
No, nowhere in there did you say, I'm assuming deep time, therefore this must be boom, boom, boom. You
exactly.
Just said, you named them. There's 3 of them, not 7. First of all, there's 3. And nowhere in that assumptions did you say anything about deep time.
Time was not referenced in any way. And if those 3 assumptions are valid, or if they are ever invalid, we can tell, then radiometric dating works. And then it gives us whatever answer it gives us. Right? It doesn't have to give us an answer of billions of years. God, if such a God existed and created the world, could have easily made it so that radiometric dating gave us an answer of 6,000 years, or gave us answers all over the place. Like every single measurement is completely unrelated because, according to these people, it has no relation to when the rocks were formed.
Yeah. And the picture that they're painting too of science and the scientific method it's insane. First of all, that you have all these evolutionists out there who are assuming, and then they have to go out and fit all their findings into a billion-year-old,
Well,
it's
a little bit of projection, I think, because that's how they approach it. They approach it with their conclusion and then work from there. So that's what everyone else must be doing, right?
Exactly. Well, the whole time he's saying that, I'm like, wait, just change out the deep time for 6,000 years old and then say, okay, I'm assuming 6,000 years old, so therefore I have to
Right. So basically their entire argument is, nuh-uh, you too, that's their entire argument.
Yeah. And you're like, nuh-uh, you 235, and then
if you don't have that amount of time, you don't have time for
evolution to have taken place.
You can't have an ape turning into a man in just 1,000 years. It needs millions of years.
Well, not even that's enough, as it turns out, but that's what they think. That's right.
Yeah.
But it's based on a belief.
Yes.
And the important thing is that the belief begins with the assumption you must explain everything in natural terms.
Yes.
And the reason is that they reject the supernatural. So if you reject the supernatural, it's the same as saying, well, there is no God.
Mm-hmm.
And that, of course, is an atheistic belief.
Mm.
So the deep time and evolutionary position is in fact based on an a priori belief.
So what he just said there, for those who missed it, is that creationism is not science. And the reason he said that is because he said the reason they come to the conclusions they do is because they reject the supernatural. They look for natural explanations. That's science, my guy. That's the scientific method. And the reason that's important is not because scientists have to assume that the supernatural does not exist a priori. Most scientists are Christians, in America at least, just because most of the population is Christian, right? And so many, many, many scientists believe in the supernatural. They believe in ghosts. They believe in all this stuff, right? But when they get to the lab, they're looking for natural explanations for what's happening. And the reason is, if you allowed supernatural explanations as your first explanation, maybe you could get there after you eliminated some natural possibilities. But if you allowed supernatural, essentially magic, if you allowed a magic to be a leading explanation right at the beginning, then it undermines your entire process, because magic can describe anything. Anything and any observation can be magic.
Yeah. You would be taking science, throwing it out, and then having endless possibilities for any of your predictions, because there's no way you could go from there. Like,
there's no falsification. There's no measurement you could take that would contradict the hypothesis of magic. For example, for accelerated nuclear decay that some creationists invoke, it requires that it releases enough heat to vaporize the Earth's crust. How did they get around that? Magic. God got rid of the heat. There's no need to go any further, right?
And contrary to what people think, science isn't about proving themselves wrong. It's about trying to prove themselves. It's trying to prove themselves right. It's about trying to prove themselves wrong.
This is a perversion of science, because they're ignoring any evidence that doesn't fit in their preconceived worldview and invoking magic anytime they can't do that, right? But worse than this, it undermines the gospel message that he is trying to say it preaches. The very message he started by saying, this is why I think creationism is true. Creationism undermines that message because it turns God into a liar. God has to be this trickster like Loki, because any honest observation of the evidence that just doesn't come in with any kind of preconceived notion of the age of the earth or whatever, if we just look at the evidence, look at the laws of physics, and let the evidence do the talking, follow it where it leads to an earth that is billions of years old. And so that means that God had to cleverly hide the truth in just such a way that an honest observer would come to the wrong conclusion. And so they would be forced to ignore what they're seeing, ignore their brain, and go with some other explanation.
Yeah.
So apparently the God he worships is a giant dick. And it's even worse because I guarantee this guy isn't a universalist. He believes that if somebody doesn't agree with this view of the earth, that God's going to put him in hell for all eternity.
This is complete lack of thinking through some of the implications of your beliefs, right?
Well, it's being so committed to what you've decided is right that no evidence can possibly sway you.
Sure. And then you have blinders on too, to all the other stuff.
Right. And I know exactly what this feels like. I was in a similar situation. I would hear things like, the earth looks old. And I would say, well, God could have made it with the appearance of age, going full in on last Thursdayism, because that's what my creationist beliefs required.
Not taking that to its conclusion, or what does that mean if he did make it look that way, right?
Right. Yeah. As I had an answer, then I stopped thinking about it, because if I thought about it too long, it would get uncomfortable,
Yeah.
You can change the assumptions around your dating methods and get any age you like, depending on the assumptions you make. But the worst thing is, you can't test any of those assumptions because they're all in the past.
Yes.
And we don't have the past.
Yes.
All we have is the present.
But you can test those dating methods. We already talked about that. I already showed you how we can test it. You can definitely test your assumptions right now in the present. You can test them.
And they'll tell you things about the past.
They'll tell you things about the past. Yes. You don't know what was in the past, but people, light takes time to travel, right? So you have never once observed something in the present. Everything you have ever observed has been in the past. But that doesn't cause us all to like collapse into a puddle of solipsism, like we understand
Nothing
that
matters. Yeah.
the past is the key to the present, And so again, unless you're going to turn God into some trickster who is hell-bent on deceiving us, and if he is, there's nothing I can do about it. Like if an all-powerful deity wants to fool me, I can't stop him. So I can't go on the assumption that that's what's happening. I have to assume the reality I'm experiencing is real.
So what you can do is test how good the dating methods are. Now, in order to do that, you need to have a rock of known age.
Well, that would be one way to test it, to have a rock of known age and see if you get the right answer. That'd be one way, maybe. Perhaps a better way to test it, though, would be to use completely independent dating methods that don't rely on radioactive decay or anything like that at all, and then see if you get the same answer, because there's no reason why they should agree, why the radioactive decay of uranium should match some completely unconnected process. So if they do match, then, that should give you confidence, right? And spoiler, they match. Some examples out of many. The ocean floor is spreading, right? As on the rifts, there's like new rock welling up from the mantle and cooling, and then so you're just getting constantly new crust being created, right? You can test, You can test. We can see how fast it's spreading. We can do radiometric dating on the rock. There's no reason why those two things should match, and yet they do. Other examples, ice cores have been done. You test how old they are by counting layer stratigraphic techniques. Those match independent krypton-krypton dating. Again, no reason at all why those two things should match if they weren't telling you the same thing, but they do match. We could go on and on and on and on and on. There are plenty of instances where multiple dating methods all converge on the same answer. This happens far more often than it doesn't. It doesn't always work. There's always going to be outliers in any method, but creationists will focus on those outliers and ignore the vast and overwhelming majority of cases.
What he's trying to imply here, though, is that we're assuming the age of the rock, and then we go to look to verify the age we assume.
That is what he's implying, and it's about to get explicit.
Oh, is it?
Oh, yeah. This is my favorite example. As soon as he said you can test rocks of a known age, I knew exactly what he was going to say. Because there's nothing new in creationism. Just for he's about to talk about Mount St. Helens.
Spoiler.
Spoiler.
How do you get a rock of known age?
Yeah.
Well, a really good way is to take a rock from the lava dome of a volcano with a known eruption date.
God, it's just been solidified. So someone saw it. It's a historical record.
That's right. So there's an historical record with a date. So we now know exactly how old the rock is. So people have taken rocks from the lava dome, for instance, of Mount St Helens. It erupted in 1980. And a rock from the lava dome was dated various samples using the potassium-argon dating method. And people got anywhere from 350,000 years to 2.8 million years old.
Wow, and it was only 1980.
Well, yes, and the rocks at the time were about 10 years old.
Mount St. Helens are probably the favorite volcano of creationists because the story sounds damning when you first hear it. We literally could watch this erupt right in front of us, watch it cool, then date it, and it comes back with an age that's 350,000 years off or something. It sounds like, oh man, this method is awful. This entire story rests on them abusing the radiometric dating method and showing absolute contempt for their audience. That no group of people despises their audience more than professional creationists. Because if their audience would look into this at all, just the slightest amount, the story immediately crumbles. But Mark is so confident that his audience won't check that he lies straight to their face. And if you look at the comments of this video, he's right, because nobody checked. So here's what's happening. We talked about potassium argon before. Potassium 40 decays into argon 40. About 10% of those decays of potassium turn into argon. It has a half-life of 1.25 billion years. So after 1.25 billion years, half of the argon will decay, right? That is slow.
Yeah, that seems pretty slow.
Right. This is important because while you can determine how fast something will decay, like large quantities of atoms, for a large group of things, you can determine very accurately its behavior. But every individual atom, you can't predict when it's going to decay. It's completely random. There's no way to pick out a potassium and say, this will decay at X moment. You can't do it. So
because you weren't there, you didn't see when it originally decayed, so now you don't know.
No, because of quantum uncertainty. So you can only make firm predictions on large numbers of atoms, right? Well, over 10 years, only 0.0000005%, that's 6 zeros, or roughly 1/1000% of the potassium-40 will have decayed, and only 10% of that will have turned into argon-40. There's just not going to be much argon there. So you're trying to do a method to test how much argon is there to measure that ratio. There's almost none to measure. So you're not going to get a statistically significant amount of argon-40. Any result you get is going to be completely meaningless. But then they'll say, well, how come you got an answer of 350,000 years then? Why did not an answer of 0 years or whatever if there was no argon, right? You should have gotten an answer of 0. Now, here's where it's one of the great ironies of creationists, because they, in one breath, they will say that scientists are unreliable, they're liars, you can't trust them, they're constantly like deceiving you. And in the very same breath, they'll say their measurements are perfect with no error. Well, which is it? Because every measurement has error. No measurement is perfect. And so in this case, the error is going to completely obliterate whatever signal you have. For example, common or modern radiometric dating is done through counting atoms using a machine that can do that. But no matter how thoroughly they clean it, there's always some little bit of the daughter atom left over, right? So if they're dating potassium argon, there's a tiny, tiny amount of argon left over from the last time. So even if they did a test with nothing there, they wouldn't get a 0 answer, right? And this is known. That's part of why there'll be uncertainties on any measurement, right? So if suppose that the amount of argon from the sample is 300,000 years worth of argon, right? That sounds bad until you know that this is supposed to be a method that you don't use on young things. If you got that amount of error is static, it doesn't change, right? It's 300,000 years. It's not like a percentage of your total argon. It's this much argon, right? And so suppose it's adding 300,000 years to the apparent age of your sample. Well, if your sample's 10 years, that's a big deal. If your sample is 3 billion years old, then adding 300,000 doesn't matter, right? That error is tiny now. And so,
can I ask a quick clarifying question? Why would we use potassium argon testing in this case then?
Well, potassium argon. So there's a lot of things that go into what test you take, and they used it because it would give them the answer they wanted. But
so this is creationists choosing to use potassium argon.
Oh yeah. Creationists took the sample, went to a lab and said, I would like you to do potassium argon dating, please. And the lab was like, so just so you guys know, if the sample's less than 2 million years, our answers are completely unreliable because of all these reasons. And
that makes more sense.
Yeah. The lab is like, you know that this is the case. And they're like, yes, test it anyway. And the lab's like, okay, but it's going to be nonsense. We'll do it if you're paying us, but it's nonsense. And so the error also makes this thing out. Another problem with potassium argon dating is that, remember how I said the argon is kicked out when it's crystallized because it's gas and it's constantly escaping? Well, it doesn't all escape. A little bit gets captured in. It's called inherited argon. And so possibly some little bit of atmospheric argon got trapped in when the crystal was made. And that'll give you a little bit of error. But again, that's a static amount of error. So if it's 300,000 years worth of error, and your sample is 10 years old, that's a big problem. If it's 300,000 years of error and you have a result of 3 billion years, then 300,000 years doesn't matter, So one last known issue with any dating method that uses crystals, not just potassium argon. So what you're dating with these radiometric dating methods is you're dating the crystal and the last time it melted. So you're measuring the age from when this crystal was formed. Now, if the crystal's in a lava flow, most of the crystals are going to have melted because they're in a lava flow. But most is not all. Occasionally, you'll get an inherited crystal, a crystal that came from the last time, or the time before that, or the time before that, right? So occasionally, you'll get a crystal that is much older than the rock it's in.
Yeah, that was going to be my question, because it seems like in an eruption, there's something erupting there, and that stuff didn't just poof into existence, and they're like dating the time that it poofed into existence, right?
Right. So the lava dome cools, it forms a bunch of new crystals, but some small number of crystals are there from the last time. And so that contributes to your potential error. Again, if you just take a bunch of samples, then you're going to get like, they're all right here, and then you have one that's like up here. Okay, well, that's probably inherited crystal or whatever. Like, you know, and they have ways to take care of this. But basically,
science has a way.
Right, science finds a way. What this is, and maybe I should have said this at the beginning to prime everybody. This is like the creationists went to, like, you know those truck scales they have on the side of the road when you're driving down the highway where trucks are supposed to go off and get weighed, right? It's like the creationist sprinkled a little pinch of salt on there, and it's like, this truck scale can't measure that salt. It's worthless. It doesn't tell you anything. How can you use it to weigh those trucks if it can't weigh this pinch of salt? You know?
Yeah. I was actually at one of those scales today because I was doing a dump run from a bunch of trash that we had. And in front of me was a big dump truck. And the scale weight it was like 30,000 pounds or something. And it kept jumping between 30,180, 30,190 pounds. It was big swings, right? So
yeah, like a 10-pound swing here or there would matter for a pinch of salt, but it doesn't matter for a 30-ton truck.
Right, you know? Exactly. Yeah.
Right. This argument is stupid. There's no polite way to say it. It is stupid, and it is insulting the intelligence of every creationist in his audience. But the sad thing is his audience is eating it up. So, yeah. It's pathetic.
And he knows it too.
Oh, he knows it. So on this channel, we are hesitant to talk about people's like motivations, because that's happening in their head and I don't have access to that. You have to work really hard for me to assume that what is happening is not incompetence, it's dishonesty. But when it comes to professional creationists, like, this guy has a PhD. I don't know this particular creationist, so maybe this guy is just a moron. But most creationists, like there's creationists who are geologists, there are creationists who are biologists. They know better. And they're not telling their audience what they know. So there's really only two options. Either the creationist in question is utterly incompetent and don't know, or they do know and they're lying. Has to be one or the other. So if you prefer this guy to be an idiot or you prefer him to be a liar, whatever explanation you want, it's one of those.
Benefit of doubt, he's an idiot. So
yeah, baby. And here's what the clip we're about to play, I think, shows that it's the liar one. But
let's dig into it.
And you read in the literature, people say things like, well, dating rocks that are young is notoriously difficult. So now just hang on a minute. Let's just think through that. I've just given you a rock to date, and you're telling me that a young rock is very hard to date, but I don't know if it's young or old. I just know I've got a rock. I want you to tell me, is it young or old? So it's an interesting admission to make, isn't it?
Yeah.
That the dating laboratories themselves say, oh, well, it's pretty hard to date young rocks. But the point is, you shouldn't get such an extraordinary range of very old ages for something which is known to be much younger.
So he's saying he's read the literature, which means he knows the problems. He knows the explanations because these explanations are in the literature. So he knows everything I just told you guys. He knows, but he's not telling his audience that.
Wow.
So,
yeah.
Yeah, as he said, it is a startling admission, but it's not the admission he thinks it is.
But if you get unreliable results for things that have a known age, how can you have confidence in the results you get for things of unknown age?
Jared, if your truck scale can't measure a pinch of salt, then how can you trust it to measure trucks?
Well,
Checkmate.
Jordan, in my kitchen, I have a scale that goes down to the 100ths for grams.
No. See, I'm not going to tell you how much the thing I want you to weigh is. You need to pick a method. And if it doesn't work for whatever arbitrary amount of stuff I have, then it doesn't work at all, period. Yeah. That's exactly what it's like. Clearly this guy knows his principle. If you're like, hey, I have a loaf of bread, can you measure it? He wouldn't be, well, do you want me to get my tiny gram scale or the massive 2-ton scale? I don't know which one you want. You know? Yeah. Okay.
Okay.
All right.
I think we've hit that home.
Yeah.
All right. So the rest of this video, we're gonna have to do at a later time because he gets into some more, some different topics.
Yeah. So we've
more
covered
geology and stuff.
Most of the radiometric dating stuff. It comes up a little bit, but it's kind of in the context of geology. So we're going to end it here. We might pick up the episode at a later date. But that means that you have made it all the way to the end. And if you make it all the way to the end, you get a fallacy of the day or bias of the day. And today it's a bias. And it's one that's particularly applicable to this episode. It is the confirmation bias. So the confirmation bias, it's almost like we planned it. Yeah. So the confirmation bias is one that I think most people have at least heard of, right? And that is the human tendency to look for evidence that matches what we want to be true, or what we already have decided is true, what we already believe. It's not just like, it's not like you have in your head, I'm only going to look for stuff that agrees with me. Like that's not.
This is a cognitive bias that kind of goes on. Yeah.
Right. And so if you believe that the Earth is 6,000 years old and you look at evidence, if you read something or you see something that contradicts what you already believe, you are less likely to remember it. You're less likely to spend time to understand it, and you're more likely to reject it, to see it as less convincing than evidence that goes along with your beliefs.
Yeah, it's very similar to counting the hits and ignoring the misses. Yeah.
Right, exactly. Humans are, just as a species, not very good at viewing things dispassionately or becoming kind of emotionally distant from the issue at hand. It makes sense why this could have happened. It's a very efficient way to process information, right? So if you already have a conclusion, presumably you got there somehow and you haven't remember, we evolved to avoid lions on the savannah, not to figure out how old the Earth was. And so hey, the information I had, the beliefs I have gotten me to this point. So they're probably decent. So I can quickly sort through new information by seeing if it matches what I already believe, which was good enough for now, right? Because evolution is the process of good enough. It
really is. Yeah.
Yeah. So that's the bias. What can we do to avoid it? Because everybody's biased. Everyone is susceptible to these cognitive biases, and we are no exception.
I have an idea.
What's that?
So if I'm reading a book and I get to the 3rd page and I already know that this confirms everything I previously held belief, I should have a red flag going off in my brain that says, hey, wait a second, Jared, you might have some confirmation bias going on here.
Right. Go beyond page 3 and seek out information that contradicts what you already believe, right? Yeah. So, for instance, when I'm looking at stuff for this channel, if I'm trying to debunk something, I usually start by just kind of I get a vague idea of what the claims are, and then I go to the people who believe it and see what they say. I start there because if another bias is anchoring bias, if I'm going to anchor to anything, I want to anchor far away from what I already believe, So basically, I try to give things that contradict my own beliefs as much I make the conscious effort to give them as fair a show as possible and to seek them out harder than I seek out stuff that I already agree with. So I'm kind of stacking the deck away from my own already held beliefs to try to counteract this bias. Because I know it's something that every human is susceptible and I'm a human. So it just needs to be something you need to take. You basically just have to take into account because you're not going to be able to stop it. But over time, as you get more practiced in recognizing it, you can, start to mitigate it.
Part of that also, too, means that you need to be willing to change your mind. If let's say you seek out that information from an opposing view and you're like, oh, wait a second, that might actually be right. If you're not willing to make that change, then you're just going to ignore that and just keep on going, right? So you have to really take it seriously.
And being wrong is nothing to be afraid of. if you take if what you care about is the truth, then if you find information that shows you're wrong, then you can just change your mind, and then you're not wrong anymore. It's too easy. Yeah, it's like magic. Boom. You can just, oh man, and then it's nothing to be embarrassed of. Everybody, if you believe the exact same things today as you believed 10 years ago, you probably haven't thought very hard in those last 10 years. So. Speaking of thinking hard, something you should think hard about is joining our Patreon, which we just launched. At the time of recording this video, it's not launched, but it will be by the time you see it. And if you've already joined, then you're watching this early, which is something you can do if you join our Patreon. You'll be able to see all our videos about a week early, definitely before all of the unwashed masses get to see it. And it'll really help out the channel. But if you don't want to do that, we totally understand. If you could just give the video a like if you did like it, comment to let us know what you thought or what you'd like us to do in the future, and we will definitely read all of your comments. We can't always respond to all of them, but we do read every single one, or at least I do. Jared doesn't read any of them, but I do. If it's a funny one, I'll send it to Jared. So
yeah.
All right, so that's our show. Do subscribe so you'll see the next one. Until then, remember, you've always got reason to doubt.
Peace out.